A light bulb manufacturer produces 35,000 light bulbs. From past data, the lifetimes of bulbs are normally distributed with a mean life of 900 hours and a standard deviation of 50 hours. So we have to predict the percentage of light bulbs that will last between 825 and 875 hours. Well, since 900 is the mean, that's what's going to go directly in the middle of this diagram. We are trying to find the percentage of light bulbs that will last between 825 and 875 hours. So I'd say that 875 is probably there and 825 is probably there. Okay, so we want the area of this shaded part. What you're going to have to do first, however, is come up with some z-scores. So I'll say this one right here is Z1 and this one right here is Z2. Okay, so for Z1, we're going to have 875 minus 900 all over 50, and that's going to give us a z-score when you work it out of negative 0.5. Next up, we want to find Z2, so it's going to be 825 minus 900 all divided by 50, which gives you a z-score of negative 1.5. Okay, so we're going to find Z1 first. If you need to expand this to 3 digits, and same with this one right here. So in this case, we're going to look for the first 2 digits along the left-hand side. It's negative 0.5, so that is right here. Okay, and the third digit is just going to be 0, which is right here. So look over here and look down, and that corresponds to an area of 0.3085. Okay, for Z2, let's look at for the first 2 digits. It's negative 1.5, so it's right here. And our third digit, which is 0. Okay, so look over and look down, and what we're going to find here is our area is going to be 0.0668. So working with this one, of course, we want that shaded part. What we don't want is what I'm going to be highlighting here in red, which is this part right here. Okay, remember that the area that we found for Z1 will refer to all of the area to the left of it, and Z2 will also refer to all the area to the left of it. Well, Z2 refers to the area that we don't want. So what we're going to do is we're going to subtract it. So you're going to have 0.3085 minus 0.0668. Okay, and when you subtract that, you're going to have 0.2417. And as a percentage, you turn that into a percentage by timesing it by 100. That's going to be 24.17%. So the question is how many of the 35,000 light bulbs would you expect to last between 825 and 875 hours? Well, in that case, you're going to multiply 35,000 by the probability, which is 0.2417, which is going to give you approximately 8,460 bulbs. Okay, so, and C, determine the probability the bulb selected at random will last less than 920 hours. Now remember, 900 is the mean, so that must mean here that we want something a little bit to the right of it. And we want here bulb selected at random will last less than 920 hours, so it's going to be the area to the left of 920. First off, though, we need to find a z-score. So z is equal to 920 minus 900, all divided by 50, and your z-score is going to be 0.40. Alright, so let's check that out on our z-score tables. Okay, so in this case, since it's positive, we're going to look at the positive z-score tables. The first 2 digits are 0.4, and the last digit is 0. Look down and look over. In that case, your area is 0.6554. So that is your probability that a bulb selected at random will last less than 920 hours.